Welcome all of you. So this is my next question from calorimetry latent heat questions. These are concise physics questions which I am doing one after the other. You'll get them in the playlist calorimetry. Just look for latent heat questions and you'll get all the sums. Okay, so let us begin. So the question looks like this. Here you have ice at 0 degrees centigrade, ice. Okay, now there is a refrigerator or something which has converted this 0 degree ice to 0 degree water. Both can stay at the same temperature, you know that. So ice has been converted to water at 0 degree all in 1 minute time. Now the same machine will change this 200 grams of water to 20 degrees centigrade. Now they are saying in how much time. They are asking for the time required, okay, to convert it from 0 degree to 20 degree. Now remember, here we will have to use, when it is a change of state from ice to water, then we will use only ml. But if it is in the same state from 0 degree to 20 degree, we will use mc theta. Let's see, I have explained this in my previous videos, you can check. Okay, so here how much of they have to gain heat. Here gaining heat is happening. Okay, so let me take the first case first. Heat gained. Okay, and the heat gained here is ml. M is 200 and L is 336. Okay, 336, because everything is in grams, so you should check this. Everything is in grams. Here this value is also in grams, these units are also in grams, so no problem, I can multiply. So here this is this amount, this many joules are gained by whatever machine it is heating up, or whatever burner it is, in just 1 minute. Okay, we are heating it, we don't need a refrigerator here. So how much is the, what is the power of that machine? Power is energy. It can be heat energy, it can be electrical energy, it can be mechanical energy. Okay, power is always, see, power is always energy by time. This has to be in seconds, this has to be in joules always. This has to be in joules and this will come in watts. I am using the same formula, only thing is here I am using heat energy, and this time 60. Why 60? Because it is we are trying to find the power in watts. Okay, so 6 here, 6. So 1120 joules is gained per minute. So this is not joules anymore, this is now watts. Okay, because I am finding power. Now I know this is the rate of heating. I have to take this water from 0 degree to 20 degree now. Now heat gained for that, taking it till 20 degree is mc theta. M is 200, C is 4.2 and theta is a 20. How much is it then? 200 into 84, that comes to 200 into 84. We will not even calculate, we'll just leave it as joules. Okay, why calculate? Okay, this is how we can do our sums faster. Now we need to find the time taken. If we go back to the power formula, power, energy, time. Okay, let us substitute. Power we know of the machine is now this. Okay, time we don't know, we are going to find in place of amount of heat that has to be given is 200 into 84. Okay, so now, the heat is written here, power is energy by time, so heat is written here by time. Okay, so now time is how much? Time is, if we have to find time is 20, this is why we don't multiply, into 84 divided by 1120. Cut this, and if we calculate this further, we'll get just a 15. Okay, so 4 here, so here we'll get a 28. Okay, so this will give me 15 seconds. Okay, so remember, as long as I have this in joules, this in watts, my answer has to come in seconds and in no other unit, because it is from the power formula. Okay, so this is how we do this question. So please watch out for my next video in calorimetry. Go to the playlist and look for it. If you have not subscribed, don't forget to subscribe. I have separate videos for specific heat questions. That is the first part of the calorimetry chapter. New videos are going to come up till your ICSE exams. So please stay tuned and don't forget to subscribe. Bye all of you.